Hello everybody, we are from Smart Mobile Media Computing Laboratory from China National University. Today I'm going to present about cooperating SDN and mobile computing for low latency of adaptive ultra-high video streaming in NFV. So firstly, I will introduce the problem of ultra-high video streaming. Then I will briefly introduce about mobile computing NFV and SDN. Then I come up with the system overview to solve the current problem of ultra-high video streaming. Then I present experiment for our proposal method. Then I conclude our research. So streaming a video with ultra high quality are dealing with the current network inherent problems such as bandwidth and latency. For example, this figure so that we have dynamic adaptive streaming is passing to the switch and a gateway to user. So the problem with we may have a problem with bandwidth fluctuation and high latency, so that user will not have a good experience with ultra high video streaming. And so dynamic adaptive streaming is widely used, even is implemented in a real business service such as YouTube and some other famous video internet provider such as Netflix, and it provides and switches between the variety of the video resolutions in one streaming session seamlessly. And the mechanism is to select streaming resolution based on the certain network conditions is still the hot topic of dynamic adaptive streaming. Then the recent research with mobile computing is still cumbersome, such as high handling load balancing between mobile X streaming servers. For example, some mobile X server handle computational requests from users, while other mobile X are idle, because it's increasing service latency because heavy load mobile X servers cannot transfer requests to idle mobile servers. But we can solve this problem by placing a coordinator server which independently executes instances mobile application. Besides, it can also decide to choose an optimal mobile server for a given request from a user. So this coordinator can handle it by software-defined networking SDN concept, and multi-access edge computing, formerly mobile computing, is a network architecture concept that enables cloud computing capabilities and an IT service environment that the edge of the cellular network and more in general the edge of any network. So the basic idea of mobile is by running applications and performing related processing tasks close to the cellular customer, network congestion is reduced and applications run better. For network functional virtualizations, is an architecture concept that uses the technologies of IT virtualization to virtualize entire classes of network node functions into building blocks that may connect a chain together to create communication services. So we have NFV manual. It was defined by a working group of European telecommunication, and this firm group consists of three major functional blocks. It's a virtual infrastructure managed and network function virtualization, orchestration, and the virtual network function manager. So we may have the VNFM is control the element management, which support to run the our real data server here. So we can stop and start it by running a script, and by using this we can reduce latency of the service. So the contribution of this paper is mainly focused on SDN for mobile app in delivering ultra high definition streaming with the following reasons. So first, SDN enables us to deploy better network functionality without the concern for hardware compatibility. And mobile gives us more adaptive to reduce latency while providing computation uploading in the dynamic adaptive streaming for HTTP. And the main drawback of DAS is the latency for mobile for media streaming. Although many cutting-edge research have been carried out to address this use improving DAS with reduced latency, and implementing mobile app for this problem has been researched probably yet. So the previous research on the adaptive streaming is that they propose a method called wireless network assisted video streaming. It deals directly with direct DAS during high demand assets to improve quality of experience. So the wireless network assisted video streaming maintain proportional bandwidth location to a client as much as mechanism to prevent commitment transmission. And they implemented that framework in NS3 simulator, and they have introduced new module of NS3 for DAS, as NS3 currently did not offer such functionality. So they adaptive framework perform overwhelming over the traditional networks. And from the base research, we consider mobile app as an SDN application and use SDN northbound interface to communicate with SDN controller. The SDN controller monitor services which run on mobile server to optimally choose a mobile server for a given request from a user, and it can optimize service based on the current condition of network service, latency, computation capacities, and storage. We employ northbound APIs to trigger commands from the SDN controller, SDN applications, just as router or switches, and it was implemented by using open flow switches. And in the research, we the mobile current node application commands are high level and cannot send command directly to the device. So to solve this problem, the command is later translated into open flow based traffic steering rules and transfer to the open flow devices. So this component can both be connected to mobile server or be part of it in the network. And the service is main mechanism for traffic routing for the mobile app applications. And in the system, mobile server are located in a location where it's near to user. Besides, its mobile server runs an adaptive streaming service which has MDP. Is a media presentation description for DAS and segment files corresponding to available streaming videos. Furthermore, it contains another record which store information of available video in the different DAS mobile X servers. With the IP, so we put IP in the record of MDP, so a client can stream with different CDN servers. CDN server here is a mobile back server, and we located the best streaming server for each video streaming resolution. For example, the client can optimally stream with the mobile X1 in the figure with the 360p 360 progressive video resolution, and it can stream with the mobile X3 with 720p resolution and mobile X2 with 2160, which is a 4K resolution. So with the extension of mobile X streaming server, we create a table for each streaming segment. So in the experiment, we compare latency between our proposed system with the NFV-based adaptive streaming system, which is our previous research. It was published in a conference in July last year. Besides, we evaluate and examine the improvement of the streaming quality of our system compared with our previous research in the same field of SDN adaptive streaming. So the main focus is to improve streaming quality of ultra high definition video, and we implemented DAS as a streaming technique in our experiment, and we use raw video file with duration is about 6.5 minutes. Then we encode and transcode those video into different resolution and fragment them in fragment this resolution into segment files with the format file from DAS. So this is separate from our network topology and is implemented in using Node.js and FFM PAG models. And for simplicity, we decode an original ultra high video with the following bitrate ranging from 144 to 4K resolution video, and we randomly select one user among 1,000 users and obtain measure streaming information. And our cheap latency comparison between our method and NFV-based streaming we achieve low latency, which is about 20% compared with our previous research, as shown in this figure with NFV-based approach with the green line, and for our proposed method in this research with the red line, and it shows that we have almost has lower latency than the previous research. And we compare our research with two methods employed mobile X as a technique to deliver ultra high definition video over the internet. So we compare streaming quality between three methods, between our method and two methods. The two compared method is SDN assisted, SDN wireless, and our proposed method, and SDN based mobile X DAS. As a result, our method obtained 5% double bit compared with the SDN assisted, and 40% double bit compared with SDN wireless method. So the difference between two SDN-based approach and our approach is more like a supporting component. And finally, in this research, we carry our research on SDN cooperating with the mobile X and NFV. The main contribution of this research was focused on the improvement of ultra high definition streaming over the internet. In fact, the control services we are deployed at the mobile server and balance loads between mobile server. Though we put a lot of effort to build the system, our measurement on the streaming system was stopped at two measurement parameters are the packet latency and streaming representation. So in the future research, we intend to investigate in reinforcement learning algorithms at MEC server and SDN control as well. So as a result, we can make a local service which is served by MEC intelligently. So this is the end of the visit. My presentation. Thanks for the listening.